All right, trigonometry. Measure of triangles. Well, then it goes into measure of just angles. It takes the angles and builds off of that as well. And lo and behold, we have a whole set of math topics that we can put under here. So today, we're going to focus on angles. All right, and the thing I'd like for you to do right now is, let's get a drawing here. Draw an X and Y axis. Come on, Evan. Draw an X and Y axis. And when we are going to, we're going to be in standard position. And I want to just kind of point out what a standard position is. On the positive x side, from the origin, the vertex is at the origin, from the positive x side is the initial side of your angle. And let me just draw it somewhere out here in the second quadrant. This side of the angle is called the terminal side of the angle. And in our positive direction, when we measure the angle, we measure from the initial side to the terminal side. Okay. So let's just take some time to draw some angles. Let's sketch some angles. And, okay, I think most of you would be pretty familiar with drawing a 45-degree angle here. There's my axes. We will draw the initial side here. And then kind of put the terminal side about where, how many degrees is it between the x-axis and the y-axis here? 90. 45 is half that, right? So let's try to split that right there. And draw the 45-degree angle there. Okay. Now I'm going to actually talk about a couple of other angles here with the 45-degree angle. See, we could go, do you know how many degrees it is here? If I go all the way around, if my initial side and my terminal side are the same thing, that's 360 degrees. Everybody good with that? Okay. Suppose, let me change colors here, that I do this. And say my angle is this angle right here. You see, I looped around past the 360 mark and went back here. What would that measure be? I heard it. 405 degrees. The green angle there, not that you can see the distinction in colors that well, but that angle right there is 405 degrees. Is everybody following me? And I could go, what if I went, and notice I went in the positive direction there. That's counterclockwise is the positive direction. But I could go this direction. Clockwise is the negative direction. And what would that measure be? If I go negative direction to here. Any thoughts? Justin? It would be negative 315 degrees. Is everybody good with that? I get all but 45 degrees from 360, right? So it's 45 degrees short of negative 360. Is everybody good with that? All right. Very good. Very good, Justin. So, (45°, 405 degrees, and negative 315 degrees are coterminal angles. They have the same initial and terminal sides. Now, your way of arriving there is different. Do you have any questions on that? Okay. Now, one more way we could look at that. 45, let's do something to it and get to 405 degrees. What do you suppose to get from 45 to 405 degrees? What could we do to 45 degrees to get 405 degrees in the context of a circle? Just some simple operation. Little arithmetic. Ella. 45 degrees plus 360 degrees is 405 degrees. Okay? That is correct. Now 45 degrees, and what could we do to it? Start with the 45 degrees and get the negative 350 degrees. I think, Justin, you kind of had to do this to get that answer, negative 315 degrees. Ben? Let's subtract 360 degrees from it, yeah. Okay? All right? Now, anybody want to tell me another coterminal measure that we have here, we could have here? Evan? Negative 405. Well, let's check that. Let's just see where we end up. Okay. You want to change that answer? I'm not going to draw on it, but I do want to, let's just kind of trace. See, there's negative 360 and then 45, so that puts us down here, doesn't it?
I'm trying to figure out what I got from
The number's going to be fairly big, whether it's positive or negative. Okay, yeah, you just add 360 or subtract 360 again, you'll get another one. Yes. And it's the number of times you want to add 360 or the number of times you want to subtract 360. If you had to get one more. So we could say, what, 360, what is that? 770 degrees if I add 360 to 405. Is that right? 765. I have no idea what I'm trying to do. Okay. 765 degrees. If I add 360 degrees, or if you subtract 360 from this, you could have what? Negative 675. Now I'm nervous. Is that right? Okay. I'll lose my confidence if I'm not careful. All right, we good there? Okay, when am I ever careful? Is that what you just said?
When are you ever not?
Okay. All right. Let's draw another angle on here. Thank you, Evan, by the way.
You're welcome.
Okay. Let's go 210 degrees. Let me have you take a guess as to where I know where your initial side is. Is everybody good that the initial side is right here? Now this is a positive angle. How far do you want to go with that?
I have a question.
Ben?
The initial side always there?
Yes. When we're doing all these in standard position, and the question is this always the initial side? The positive x direction is the positive x side is, yes, the initial side. So, 210 degrees. All right, tell me, how far have I gone right now? How far have I gone now? If I go all the way here, I'm at 270. I don't want to do that, huh? So we got to figure out about 30 degrees. Does that look about right?
About a third.
Yeah, a third of the way, but okay, I might be a little far on that, but good enough for government work, right? Okay, so there is 210 degrees. If anybody has family that works for the government, I apologize for that comment. All right.
I don't get it.
So, now, how about you draw and put the measures of two coterminal angles? I want a negative coterminal angle and I want a positive coterminal angle with 210 degrees. Everybody with me? One negative and one positive. Murphy, do you have one of them? No. Not yet? Okay. Taylor, do you have one?
I did 210 minus 360, but
Negative 150. Okay, there's negative 150 degrees there. And the arrow is important because it says we're going in the negative direction here. And you said 210 degrees minus 360 degrees to get that. And that is correct. Okay. And Colleen, do you have a positive coterminal with 210? 570? So if we go all the way around, there's 360. And we end up at this terminal side, that is 570 degrees. That's looking pretty cool, huh? All right. Let's try a little bit more, this time with negative 320 degrees. Who we got absent? I don't see Ryan Williams, do I? Hmm? Oh, that's right. That's right. Oh, and that's why I'm recording this. Okay. All right. So, negative 320 degrees. I'm going to draw my initial side. And then try to come up with, after you get it drawn, it's negative, right? I'm at negative 90, negative 180, negative 270. Oh, about 50 degrees, right? That's a little closer to here than it is to there. I'm trying to do that anyway. Negative 320 degrees, that look good to you? Okay. Looks like Pac-Man to me.
That's what I said.
Oh, great minds think alike here. So, give me, if you would please, let's go a positive coterminal angle with this, and one more negative coterminal angle. Okay, do we have a positive? How many degrees would this angle here if I go this direction? Oops, I forgot to put an arrow on that one. If I go that direction, that's a 40-degree angle. You are correct. Okay. I need another negative. I have the positive. I want a negative coterminal. Justin? Negative 680. That goes way around there, huh? Okay. There's negative 360 plus negative 320, right? Is negative 680 degrees. All right. Okay. I think I want you to do one more, guys. Let's do one more. This time, let's do it with a 490-degree angle. $490-degree angle. Draw it, and then let's come up with a couple more coterminal angles. A positive one and a negative one beyond the 490. I'm going to ask you to give me the smallest possible of each, or the two closest to zero, I should say. Then. Two coterminal angles as close to zero as possible. 490. There's 360. That's 450, right? Almost halfway, not quite. There's my 490-degree angle. Okay, Maggie, do you have one of the coterminal angle measures I could put on here?
No.
Not yet? Okay. All right.
I'm still drawing it.
Okay, I'm going to get back to Murphy here. Do you have one now, Murphy? 850? Okay. Oh, I'm going to get dizzy with this one, Murphy. So, the 850, that was adding 360, right? 360. 720. 850. Now, my question, is that the smallest positive one we can have? It is a coterminal angle. All right? Annie?
130.
130? Does that get us kind of a direct route? So there's 130 degrees. Okay, what is the negative one? Okay. Maggie, are you ready to give me the negative one?
That is the negative one.
What?
130, isn't it? What? Yeah.
No, this is actually positive. Okay. Evan, stay out of it.
But 490 minus 360 is 130.
Right, but that's not a negative number.
So then what do you subtract from it?
Subtract 360 again. 130 minus 360.
Oh, okay.
So just keep three. If it's big like that, you can just.
Negative 230.
You can keep subtracting until you get the negative one here.
Okay.
All right? You bring up a good point. Okay, so we go this direction, and does that make sense? 90, negative 90, negative 180. This should be about 50 more, negative 230. All right, how are we doing? Okay. Now, we are going to, in the last 10 minutes here, look at another way of measuring angles. We just used degrees a whole bunch here, right?
Yeah.
There are other ways of measuring angles. You know, you got feet and meters. You have degrees for angles, and you have radians. This is another way of measuring angles. There's gradients, yes. And I did that in high school, and I'd have to look it up again to remember what it was about. But I have done those before. It was actually Mr. Byrne taught me. Okay. Now, okay, I'm just going to, I should have drawn the circle first. Okay, well, hold on. Sometimes you got to understand that was freehand, guys, and sometimes you just got to take a look and say, wow, he just did that freehand. Okay. No. All right. Moving on, though. I'll quit admiring my work. The thing I want you to do and note here is that this circle has a radius r. Okay? Circle has a radius r. And here's how a radian is defined. How wide a radian is. One single radian. Okay? You go along here and you follow this circle. You know it's curved, right? But if that distance that it's curved is the same distance as the radius, S, that is our kind of our common variable we use for arc length. If S is the same as that radius, S equals R, then I put a little theta, the Greek letter theta. You with me?
Not really.
Okay. I'm sorry. I'm just kind of eyeballing it. I'm not doing anything.
What is that symbol?
Oh, this? This is a Greek letter, and it's theta. Okay, and it's very common for angles in trigonometry. So there you are. We've introduced you to theta.
Is it an O and a line in the middle bit?
Pretty much, yeah. And in this, when S is equal to R, theta is equal to 1 radian. That's how wide a radian is. It's the angle that it takes to cut off an arc the same length of the radius. So you with me there? Okay. All right. Now, as you take a look here, I probably should have been a little bit higher. I think I cut that arc length just by eyeballing is a little smaller. But if I were to take this and just keep going like to here and say that's another, does that look about the same, that angle about the same as that? It might be a little wider, but it should have ended up here. I misdrew this one a little bit. Okay? And if I do it again, and I draw another radian here, okay, here's 1, here's 2, here's 3 radians already, okay? And if I draw it again, I'm going to get around the circle here. That's my goal here. Right around here. There's a fourth radian. And then I draw another radian. Let's say I end up like right around here. Are these angles all about the same? There's a fifth radian. And then I don't quite get, that's too much for another radian, right? It falls a little bit short. Here is the sixth radian here. So it's 6 radians, almost 6 radians around the circle. Anybody have any thought as to how many radians it is actually around the circle? For me to get the rest of the way here, what fraction of a radian do I need? Half. We could guess a little bit, but there's something to this that relates to circles and circumference and that sort of thing. Okay, almost. What's pi equal, approximately? Okay, 3.14. Here's 1, here's 2, here's 3. That's probably 0.14 there, isn't it? That's half a circle. 4, 5, 6. Wait, double 3.14? 6.28. Okay, and that is 2 times pi. All the way around is 2 times pi. Does everybody agree that the circumference of this circle is 2 times pi times the radius?
Yeah, 2 pi r.
And if we do the radius as kind of 1, like for a unit circle, the circumference is 2 times pi. Okay, this is important. 2 pi radians is equal to 360 degrees. And if I divide both sides by 2, I have pi radians. 2 pi divided by 2 is pi radians equals, and this is what Lance kind of led us to, 180 degrees. You with me there? That's equivalent. That's like 3 feet equal a yard. You're measuring the same thing. You're measuring lengths in that case. Here you're measuring angle measures. Pi radians is equal to 180 degrees. And pi is about 3.14. Okay. I don't think we're going to get too much more done. This is just the introduction. How did it go?
Yes.
Okay, so yikes, you say?
Yes.
Okay, I think familiarity will breed a little more understanding.
I already did the notes for Monday, and those make more sense than what we did today.
Okay, but I had to start with this. I had to get there. We had to know why this was the case.
Okay.
Okay? All right. All right, and I probably didn't get quite as far, but all right, yeah, I put those notes up, and you guys get them early when I do that. All right, 1 second here.